Okay, so we're going to look at another one that has a fraction on the bottom. So like we talked about before, we're going to first rewrite this one, get it into a more familiar form. So for this one, we have y equals, there's a negative there. I'm going to change the 1/2 into a negative exponent. So we change it into 2 to the negative 1. So now we have that as our equation. The negative in here, remember we multiply exponents, we have a power raised to another power. So when we rewrite that, we're going to get negative 2 to negative x plus 3. These two negatives do not cancel. Okay, one's out front and the one's in exponent position, so you can't bring any of that down and cancel it. So this is going to be our equation that we're going to graph. Notice we have two negatives here, so we're going to have two flips going on with it. So we always begin with the base graph. So we have, this time, we're using y equals 2 to the x, which is going to look real similar to 3 to the x and 4 to the x graph. Okay. Still, we got our key point that goes through there, 0, 1. So that's our base graph. Next thing we're going to do is we're going to apply. Now it doesn't matter which negative that you apply first. I'll start with the exponent because it's still going to be following our order of operations. So I'm going to do y equals 2, I'm just going to do 2 to the negative x. So as I mentioned before, if you have a negative in the exponent position, what that does is it flips the graph over the vertical axis. So our pivot point is here, that point. So this one is going to, still going to go through 0, 1, but now it's going to look something like this. It's going to now fall. So we take the graph and flip it over the vertical axis, and now it's going to fall and look something like that. And that would be the graph of 2 to the negative x. Now, the next one we're going to do is we're now going to apply the negative on the outside. So we're going to do both of those. We're going to do negative 2 to negative x. We've already graphed 2 to the negative x, which is this one. The negative that's out front, what that does is that's going to take this graph and do this. It's going to flip it over the horizontal axis. So it was going up, now it's going to go down. The point that was up there at 0, 1, that gets flipped down to here. So now it's going to go through 0, negative 1. The graph itself is now going to look like that. So it was going up, we flip it over, now it's going to be going down. So that would be negative 2 to negative x. The last thing we want to do is now add the plus 3 to it. So we're going to do y equals negative 2 to negative x plus 3. That's going to be our final answer, the final graph. So what we do is we're going to take this and we're going to add 3, so the whole graph will shift up 3. We can find out the horizontal asymptote because that's the number right after the exponent part of the equation there. So we'll put y equals, and then it's going to be y equals 3. So we can show that here. We're going to draw the horizontal asymptote with a dotted line there. Now this point, that's going to move up 3. So 1, 2, 3, it's going to end up right here. So that point again, we shifted it up 3 units to that position there. And the graph's going to look exactly the same as this one. So the graph's going to come along here, follow that, and then it's going to fall and cross somewhere on the x-axis there. This particular one doesn't ask for intercepts, so we don't have to know exactly where that crosses. We're just making rough sketches here in this case. So this is what your final graph would look like. Domain, negative infinity to positive infinity. Once again, no surprises here because there's no restriction in what values you can put in for x. For the range, it's talking about what y values the graph is using. In this case, the graph is only using values that are less than 3. So it's going from 3 all the way down to negative infinity. So when we write our interval notation, we put the smaller number first. So we're going to go negative infinity to 3. And then once again, we're going to use a parenthesis on that because the graph is never actually going to reach the horizontal asymptote.